Good evening, and my name is Clifford Susu from Group 1, and we are here to present on Student Record Management System. Our project is titled Student Record Management System. It is developed in C++ using the object-oriented programming paradigm. This problem was aimed to solve the difficulty in managing students using data manually, methods like paper records or unstructured spreadsheets, which can be disorganized and prone to loss. Our system provides a structured, automated, and reliable way to store, research, update, and delete student records while keeping them secure and persistent. This application is intended for school administrators, teachers, and academic record officers who need an efficient tool for managing student details.
My name is Simon Jenfrey, and I'm presenting on demonstration of key features. The main features of our system include adding new student record using both personal and academic information, viewing all stored student record in a clean table format. We also have updating student department, deleting student record, searching for students using roll number, storing data persistently using file so it remains after the program closes.
I'm Stephanie Kantalabi, and I'm here to give a live walkthrough of how our user interacts with our application. So here's how the user interacts with our application. When the program starts, it loads an existing student data from the file. If the user chooses to add a student, they immediately enter their name. Let's take for example, let's say Stephanie, yeah. Then they add the age to, let's say 19. Then the row number, we can choose a row number to be like 1. Then the department, let's say biomedical engineering, yes. So after that is done, this record is saved immediately to the file. They can then search for a student, update their department, change their roll number, delete a record, or view all students. Any change is instantly reflected in the file for persistence. Thank you.
Hello, my name is Eunice Ashman, and just as stated by my teammates, our goal is to also work on the student management systems, which is also written in C++ using with the object-oriented and paradigms. So our goal is to store, retrieve, update, delete, and also view the students' records while keeping them extendable. So we incorporate certain features like encapsulation, polymorphism, incorporate inheritance, and basically most of the things we learned in class, object classes, you see them in the code. So the program reads and writes data to a text file, then it allows records to remain available even after we close the application.
Hi, I'm Gloria Sechi. So the first key feature we are going to talk about is base class. So we are going to create a base class called person that will store common details like name and age. And these are protected members so derived classes can access them while still keeping them secure from outside code. So the class has virtual inputs and display functions as we can see on the screen over there so that other classes can override them to handle their own data formats.
I am John Lacinta Kao Jr. Okay, so we are going to add the students class, which will inherit from the person class, which is the parents class. And that's going to add a row number in the department as extra data field. And first, we have to create a function, the input, which will input the person's information. And then we are going to create a display, which will display the person's information for us. And this is going to display their personal and academic performance and their information. And this code will be used anytime you want, as it has inherited from the parents class, which is the person.
My name is Odro Muhammad Abdul Latif, and I'm presenting on polymorphism. Polymorphism is used through the virtual functions in the person's class. When a person pointer or reference points to a person object, the overriding method in students are called instead of the base version. This lets us handle different types of people in the system without rewriting code. Data encapsulation and accesses. We follow the principle of encapsulation by keeping data like roll number and department private or protected. We provided public getters and setters method to control access. This prevents invalid changes and helps maintain data integrity. File handling for persistence. We implemented persistent storage using C++ file streams. The to-file string method converts a student's data into a pipe-separated format for saving. The form file string method reads the file line by line, and recreates students' objects. This ensures records remain available even after restarting the program. Student manager or management class student manager. The student manager class handles all operations on the student list. It uses a vector of student objects and provides methods to load, save, add, view, search, update, and delete. This keeps the main function clean and centralizes the management logic. Search, update, and delete implementation. Searching is done by checking each student's roll number, updating changes a specific field like the department, and then save the updated list to the file. Deleting removes a student from the vector and rewrites the file without that record. These functions work smoothly because they are well structured inside the manager class. Thank you.
Challenging aspect of our work. One of the tricky parts of our program was making sure that whenever a student details were updated or deleted, the changes were going to be saved properly in both the program's memory and in the file. And this was brought to resolution by making one class, that's the student manager class, handle all file saving so that nothing gets out of sync. The second challenge was deciding how to save the data in a file so that it could be read back and without error easily. Now, instead of dumping raw data, we created a format which allows each student's details to be stored in a single line with a vertical bar symbol, separating each piece of the information from the other. Now, this makes it easy to save and load the records, even if the names have spaces in them. Finally, we designed the system to be flexible in that we could add different people in the future, let's say teachers. The structure supports different record types without having to rewrite the entire program.
So, in summary, our student record management system solves the problem of unorganized student data by providing an automated file-based solution that is reliable and efficient. In future, we could add sorting, search filters, password protection, and a graphical user interface to make it more user-friendly. Thank you very much for your attention.